So we've looked at Newton's first and second law. We now have a look at Newton's third law. You can see there the short way of remembering this one is that it's about action-reaction pairs. The slightly longer explanation is for every action there is an equal and opposite reaction. When we say action and reaction here, what we really mean is an action force and a reaction force. So another way to think of it that's a little bit more detailed, if one object exerts a force on a second object, so that would be the action force. The reaction force, the second object will exert a force that's equal in size and opposite in direction. And we'll exert that force on the first object. Now, I want to make a note here that this particular point sometimes slips under the radar, but it's a very key point in making a very clear understanding of Newton's third law. And that point is that for Newton's third law, two objects are involved. And when I say objects, I use that term a little bit loosely, because in some cases the object might be, say, a gas, or something that's not sort of a solid object. So with Newton's third law, two objects are involved, and just as a side note here, Newton's first and second law, so Newton 1 and 2, they only concern a single object. So we talk about the forces acting on an object for Newton's first and second law. For Newton's third law, we talk about two objects that are interacting. So if you can store that in the back of your mind, it will help to make Newton's third law make a lot more sense. To give you an example here that is fairly useful way to make sense of Newton's third law, imagine we have a golf ball that's being hit by a golf club. So there's the ball, and we've got a club that's just making contact with it. Say it's an iron of some description, and so this club is moving in this direction with some velocity v, and the ball is currently stationary. In this scenario, the action force will be the force of the club onto the ball. So I'll call that one Fa. For action force. So in this case, the action force is the force of the club onto the ball. So notice we've had to talk about two objects there. The club is exerting a force onto the ball. Now the equal and opposite reaction force is then going to be obviously in the opposite direction. We'll call that one Fr for reaction. The reaction force here is the force of the ball onto the club. So notice they're literally the reverse of each other. Force of the club onto the ball and force of the ball onto the club. You might then sit there and think, well, hang on, why is it that the ball moves? The club sort of keeps moving, but the ball's the one that seems to accelerate. The thing to keep in mind there, I'll just jot that question down. In that scenario, if you think about the ball, it now has an unbalanced force acting on it. And that's basically Newton's second law. So that explains the ball moving, but then you might sort of think, well, okay, so that's accelerating. You've also, at the same time though, you have an unbalanced force acting on the club. Note here that the direction of that force is opposite to its velocity. And again, that's another example of Newton's second law. And because that force is in the opposite direction, it causes the club to decelerate. So the club does slow down a little bit, not all that noticeable, but the force acting on the club does cause it to decelerate just a little bit. So that's an example where you've got one object connecting with another, sort of there's motion involved. I just want to tie back into one last scenario, and similar to something that we've looked at before. So let's say we've got this object on the ground, and it's a cute little object, has a nose and a mouth. In this case, we don't have any motion. We simply have something that's stationary, but we still have Newton's third law at play here. So dog sleeping on the ground. In that case, we can say that there is a force of the dog onto the ground. So we'd call that, say, our action force. In this case, that action force will actually be equal to the weight of the dog. So that action force is the weight of the dog onto the ground. And the reaction force will be then the force of the ground onto the dog. And because those forces are balanced, or they're equal and opposite, we can say that Newton's third law is at play here. Now you might notice we've got two different scenarios, one where we have some motion involved and another where nothing's moving. So the last thing I'll just point out here, basically sort of got this situation that any time Newton's first law or Newton's second law apply, Newton's third law will also apply. And that sort of makes sense if you think about it. Newton's first law, when forces are balanced, so if you've got forces acting on an object, there must be reaction forces. For Newton's second law, if you've got an unbalanced force acting on an object, there will always be a force in the opposite direction. So if you think about the car accelerating, for example, there is a force of the tyres on the road that cause the car to accelerate. You've also got force of the road onto the tyres. So every time you have a force, whether it's Newton's first or second law, Newton's third law will also apply. In many cases, though, we're not particularly interested in the reaction force. We're only interested in the applied force that causes the motion.